I would like to talk today about some of the work I've been doing with the Elgin specimens for my postdoc at the National Museum of Scotland. The animal I'm looking at in my project are the Triassic animals, so they include Erpetosuchus, which is a distant relative of crocodiles, Erpetosuchus, Brachyrhinodon, Leptopleron, and then two close relatives of dinosaurs and pterosaurs, which are Saltopus and Scleromoculus. So first of all, why are we working on this? So these are worldwide important specimens, so they record a particular time in the Permian and Triassic. What I will be focusing are the Triassic specimens. And they are important because they are thought to be closely related to the evolution of major groups. So we're talking things like dinosaurs, pterosaurs, lizards, and so on. So it's a sort of the beginning of the evolution of the modern fauna, terrestrial fauna. So one problem with the Elgin specimen, as you can see from the specimen there, is that they are poorly preserved. So most of the bones have gone or reduced to crumbles, and so what is left are cavities or some bone paste within the hard sandstone. These are very hard to prepare. And so the way that people in the past have worked on these specimens was to replace the bone materials, wash it out away, and create peels with a plastic material and study the specimen from the negative impression of the peels in the plastics. Now, there are a few problems with this. For instance, not all the cavities can be reached, so there may be some part of the scans that are still embedded into the matrix of the sandstone that we do not know about, or simply the plastic material is not liquid enough to reach every single, all the part of the bones that are preserved. The other problem is that when you have two surfaces, you make the peels of both of them, so you are left with two different surfaces to look at things, and this is a problem if the bones that you are looking at is split between two blocks. So what I've been doing in the last 2 or 3 years is taking the specimens, putting them together, and then CT scanning, which is essentially a procedure that people do even in medicine, so looking inside the body with a CAT scan. It's sort of a CAT scan but for fossils, so higher energy. And in this way we can look inside the matrix and see with X-rays what is going on. When we do this, the specimen rotates inside of the machine, which means that we can then 3D reconstruct the old specimens instead of having a 2D surface. So some of the smaller reptiles, for instance, Leptopleron or Brachyrhinodon, are those that have suffered the most for the fact that the peels did not reach all the parts of the skeletons. And so those are the most promising ones to apply this technique to. And it has been quite promising. So we got some nice results. So we demonstrate that there's a lot more to understand and to discover about these specimens, even specimens that have been around museums for 100 or more years. The other advantage of CT scans is that once you have the 3D surfaces, you can then 3D print the bones as they would be in normal size, or even make them bigger. So, for instance, I have some examples here of the little jaw of a close relative of a crocodile called Erpetosuchus. So this specimen had been printed 4 times its real size, and it was completely embedded in a sandstone block, so it was not visible in the surface. But it gives us a lot of new information about Erpetosuchus and how it relates to other animals. In the same block, we found other things. So we have here a femur, so the thigh bone of the same animal, which was not previously known. So we added a lot of more information about this animal. The other interesting thing from that specimen is is this bit that in fact does not belong to Erpetosuchus, but it's another animal that was that essentially died together and closely associated to that. And this tells us that these animals were probably living together and in close vicinities. So this is the jaw of a parareptiles called Leptopleuron, which was also a smaller lizard-like animal. The nice things of this project is that besides the fact that we are able to understand more about this animal, we get to reconstruct their aspect. So we get to update our knowledge about them and so correct the misunderstanding that have been passed through the years from the previous information, limited information that we had. And that's really fascinating to me. So not only we are learning more about their aspect, how their bones were, but also their relationships, so how they relate to the origins of major groups and so on. So because how successful the CT scan were on these Triassic specimens and how much we learned from them, we ought to expand some of use some of the same technique to the Permian specimen in order to understand more about them as well.